order it.
Start well.
So, my name's Anthony Kasza, and I work for OpenDNS. I'm a researcher, as my introduction said, and this is Dhia Mahjoub. And the title of our talk is Infrastructure Tracking with Passive Monitoring and Active Probing. And sort of the main underlying theme in this talk is threat intelligence. And you're probably saying, oh, threat intelligence, that's a buzzword. Like, we hear that all the time in the InfoSec community. What is it? How's it defined? All that stuff. So we're going to try and answer those questions throughout this talk. So we'll get started. But before we do, I'm going to tell a little story. The main case study in this presentation was the GameOver Zeus botnet that we were tracking for a series of months. And after doing so, we collected enough C2 domains that we felt comfortable contacting some of the registrars and asking them if they were willing to cooperate with us in either shutting down the domains or tracking who's registering the domains, that kind of stuff. And it was kind of interesting. This happened on November 11th of last year. And we measured abuse desk response times. Half of the registrars that we contacted actually got back to us. Kudos to WebFusion for getting back to us in under 2 hours. It's kind of a surprise to me today Nick actually got back to us, but it was a week later. And the other half of the registrars have yet to email me back saying, sure, we'll work with you, or what are you talking about? So kind of interesting. Anyways.
So let us introduce ourselves with some more detail. So my name is Dhia Mahjoub, and I'm a senior security researcher at OpenDNS. My kind of interests are into networks, DNS, threat detection, and graphs.
And as I said, my name is Anthony Kasza. I'm very similar interests to Dhia. We work on the same team. I like network protocols and bro IDS forever. Woo. Anyway.
So let's kind of cover our agenda for today. So we'll cover kind of the importance of threat intelligence as far as we're concerned. And the motivation is, in this talk, is to basically share some of our experience and practices in how we gather intelligence to kind of do our job. And we'll cover like a few techniques we use to gather this network intelligence, mainly active probing and passive monitoring. And then we'll dig into a couple use cases. The first one will be covering a fast flex proxy network, typically the ZBot one. And then the second one will be the new GameOver Zeus botnet. And then we'll conclude with some observations. So this is OpenDNS's worldwide network. We have 23 data centers across 4 continents. And that allows us to see a lot of traffic, mainly DNS, but it's of 2 types. So we have the recursive traffic, which is basically the client IP querying domains. So they're talking to our recursive resolvers. And that allows us to see all kinds of behavior from the client side. And then on the other side, you have the authoritative traffic. And this is basically the traffic between our resolvers and the authoritative name servers of the internet. And that allows us to build our own passive DNS kind of database. So what is threat intelligence? Again, as Anthony mentioned, you might have a lot of definitions depending on your interest or context or focus. But for us, we feel threat intelligence is any relevant, timely, or useful information that helps you take action, whether strategically or tactically. And some of the tactical actions you might take, as far as we are concerned, since we're dealing with malicious domains and IPs and that kind of thing, is basically block known malicious domains or IPs. Or if you gather enough intelligence, you can go and proactively block IP infrastructure that you know will be delivering attacks. So you kind of preemptively go and block them before they even start delivering the attacks. And then the other kind of action you might take if you have enough good intelligence is to investigate domain patterns, like certain behavior in the client side, and then also IP infrastructure as it's moving or like being set up to deliver attacks. And finally, if you find malware samples related to some anomalous traffic or behavior on the IP infrastructure, you can go and kind of investigate that further, and you kind of extend your intelligence.
Okay, so let's talk about some collection techniques. The first one we'll discuss, as our agenda stated, was active probing. And we've sort of defined active probing as current state, or like what is happening right now. So you go out and you touch something, or you do a query, and you get the result back, and that's intelligence right now. That could change in the future, but you know that is the current state. And you're either investigating a specific thing or a specific thing's neighbors to see where that thing kind of lies in maybe an IP range or what other domains are on that IP address, et cetera, et cetera. And we've broken active probing down into two subgroups, direct and indirect. Direct, where you go out and you actually interact with the thing that you're investigating. So maybe you do a port scan on the system. And indirect, where you simply ask around about that system. So you're not actually communicating directly with it.
So to take a specific example in the active probing direct approach, so you do a port scan, or you kind of grab the service banners of the services running. You can use the Shodan API or database, or you can do your own nmap or mass scan. And this is an example here of this range of 3 IPs, and they share the same server setup, so you have 2 open ports. And in fact, these 3 IPs were delivering like the Angular exploit kit very recently. And they were set up in bulk just to deliver this attack. So when you gather this intelligence about neighboring IP ranges that have the same server setup, you can kind of predict in advance that they will be delivering the same attack and just block them beforehand. So this has been kind of confirmed through our research, and we are able to kind of block things before they even happen. The other way is to kind of collect content, whether it's an FTP or HTTP server, but this one is kind of noisy and detectable because if the bad actor sees that you're kind of probing his infrastructure, he might block you on the source IP, or he can like return some bogus information or data.
And the sort of flip side of direct would be indirect, and I think we missed a slide. Anyways, so we've defined indirect to be like not actually communicating with the thing that we're investigating, and it breaks down into sort of 3 subgroups. DNS, or looking through mappings in the DNS, what resource records map to what IP address or domain. BGP, as well as IP whois information, and domain whois. So you can get things such as the authoritative name servers for a domain that you're investigating, the registrar, registrant information, created update, expired times on domains, etc.
So to be specific, when you're doing active probe and indirect on the DNS records, you're typically, as you all know, looking for the A record, or you're looking for the name servers of the domain, or you're looking also for the IP of the name server. And then, again, this can be considered noisy and detectable if the bad guys or actors behind the name server infrastructure are operating their own, so they will see it in their logs that you're kind of probing their name servers to ask for the records you're interested in. To do massive or like scalable kind of resolution, you can use those tools, these couple tools, ADNS and also Mass Resolver. So they're very kind of scalable, and they're worth checking out. Now, if you're looking for the IP infrastructure, the 2 main important information you want to gather is the BGP information. So typically, the prefix to which the IP belongs, as you all know, and also the ASN, but also the whois about the IP, and that allows you to see kind of the smaller granularity in terms of the slash, or like the range where the IP lives. So you can do IP to ASN mapping using Team Cymru, or you can build your own kind of scripts and programs by downloading the route views BGP tables, or if you operate your own like global network where you can basically have a lot of routers with those tables. And then you can use like libraries like PyASN if you're using Python to make like the mapping between the IP to the ASN by having like the closest matching prefix to your IP. The other important thing that we introduced and discussed last summer at Black Hat is this concept of what we call a sibling peripheral neighbors or nodes. And this is basically when you take an ASN and then you look at the upstream provider, and then from the upstream provider you go down to all of the downstream. And in other words, you're trying to find all of the siblings of that ASN that you started with. And we saw from research that a lot of times some malicious infrastructure is set up such that they have a common upstream, And then all of the kind of sibling ASNs, they share the same setup, and they're delivering like similar attacks. And this is kind of interesting and effective in kind of casting a bigger net to catch bad stuff on the internet. And then the other important fact here is that when you do IP to prefix mapping, you might have like a very large prefix, let's say /19, and that's a very coarse granularity. Whereas if you go and dig into the client that got a smaller range from the bigger provider, you might find that actually it's a /25 or /28, which is a much finer granularity, and it helps you see, let's say this is a smaller hosting provider in some country, and it's getting like some IP space from a bigger provider like OVH or LeaseWeb or RedStation. And we found again by kind of extensive research that this gives you like a much better intelligence to decide whether this IP infrastructure is bad or kind of or good. And these are like some examples of these small scale providers that are being abused recently for exploit kit attacks and malware kind of hosting. So just for your reference, this is like one in North America. So the point is we see abused hosting providers in both the ARIN and RIPE space. So this is one of them. And recently we saw a couple ranges here. Again, they are contiguous IPs sharing the same server setup, and then they were delivering exploit kit attacks. Now the other kind of MO that we noticed recently for the past few months is that these bad actors kind of delivering exploit kits, they will go and use compromised domains. And then they will inject subdomains under them, and then they point these subdomains to IPs hosting the exploit kit. So again, by kind of monitoring the IP infrastructure and the domain behavior, the DNS behavior, you're able to see the kind of the evolution and the evasion techniques that these bad guys are kind of using. And you can go back to our Black Hat talk to see more details about this approach. Now, a few more just for your reference. This is another provider that is delivering like bad content. So King servers, just another one. And this one just popped up recently. Now that SPN concept we just mentioned, the sibling peripheral neighbors or nodes, here I just took an example. So I started with the ASN in Orange, 47145. So that guy, it had a lot of IPs that were kind of compromised and hosting fast flex domains that are acting as ZBot CNCs. And then by exploring, by using that kind of method of looking at all of the sibling peripheral ASNs, basically the brothers and sisters, let's say, via the upstream provider, we found that a bunch of others were also hosting IPs that are compromised and delivering CNCs for ZBot. So again, you might just go and grab IPs and then do the mapping of ASNs, and that's kind of a one-dimensional, but if you kind of use the graph approach, it might give you like a better perspective of how things are set up on the wider internet space.
And so finally, we have domain whois data for indirect active probing, which, as we stated before, can give you information about the authoritative name servers, the authoritative domain for those name servers instead of just ns.evil.com. Like evil.com is interesting. Registrars, registrants. Some of the issues that you kind of run into with whois data is if you get it from like a bulk provider, it's a very coarse granularity. So if the domain changes owners 5 times in a single day, and you're getting daily updates from your bulk provider, you're only going to see the last owner of that domain and not the 4 before it, which is kind of an issue. And again, like whois data comes from registrants, so you can't necessarily trust it because they can always provide fake or privacy protected information, which is kind of a pain in the ass. Some tools like the whois command line client, right? There are some web services that offer this, and there's some commercial offerings that do bulk and historic whois information. And just as a quick review, because sometimes people get confused around terms, registrants are people that buy domains. They provide resource records and contact information to either resellers or registrars. And then that registrar turns around and hands that information to a registry, which inserts the resource records into the domain name system so that domains will resolve. So now that we've discussed active monitoring, or active probing, I'm sorry, we'll discuss passive monitoring. And we've decided that passive monitoring for our use is the historic state of something or patterns that you've derived from previously seen behaviors. And it breaks down into a few different categories. Of course, for us, because we have such a large DNS infrastructure, passive DNS, correlation between registration information, client query patterns, as well as correlation between malware samples. So if you execute a piece of malware, extract the artifacts from it, and then do correlation with the data that you have. And there's always syncholling.
So the previous slide we showed like different models or kind of heuristics you can use to start your investigative intelligence gathering. So this kind of workflow shows you that you can have interchangeable models. So the starting point is any model that uses a traffic. So in this case, if you have like a fast flux model or like a seed that has a lot of samples from which you extract the network kind of trace report, or you can have like a DGA model that kind of looks for lexical features of domains and flags those that are suspicious, or you can have any other models. The thing is, once you get like domains that you want to start with, you can pivot around any one of those artifacts that are interesting to you. So domains, IPs, samples, traffic features, co-occurrences. I'll explain what co-occurrences are in a few minutes. But then once you pivot around those artifacts, you'll gather extra kind of domains or IPs or artifacts, and then you'll have to apply filtering heuristics to eliminate anything that is not of interest to you. So any false positives or any kind of domains or IPs that are not belonging to the cluster you're looking for. So this is kind of a workflow that we found very lightweight and effective. So we don't need to kind of use a lot of training phases to kind of get good results with this. And then once you extract or output domains or like artifacts, you can just put them back into the beginning process and the loop goes again. So pivoting around different seeds, you can start with the domain, resolve the IP, and then from the IP get all of the other domains that resolve to it. Again, you'll have to kind of do a lot of filtering to eliminate any false positives and things that are not of interest to you. But this is kind of a typical approach that all of us know about. You can also pivot around the name servers, as we all know. And these are effective in certain attack types. So like fast flux, exploit kit domains, and also some maybe targeted attacks if the bad guys will use like the same name server infrastructure. And you can also do correlation via registrant email. So you just grab like domains that you start with, and then you grab the registrant email, and then from there you get all of the domains that have been registered with that registrant. And then obviously you'll have to do filtering heuristics to remove any false positives. So we found that this was very effective, at least in a couple cases. There are a lot of other cases depending on your kind of focus. So the first one is it's effective for compromised domains. So we see a lot of compromised domains where the registrant email is basically having hundreds or thousands of domains kind of attached to it. And then if a few of those domains are kind of compromised and injected with subdomains to deliver exploit kit attacks, you'll assume, and then we confirmed it like later on, that all of the rest, or maybe a high percentage of the other domains, will be delivering the same attack in the next few days or weeks. So it's kind of, again, like a proactive approach to kind of sweep for badness before it even starts, it becomes active. And the second approach is for malware-dedicated CNC domains. So you'll see a lot of times, you know, the actors register domains and they start using them for kind of malware CNC. And this was typical in the Zeus GameOver, but also the ZBot fast flux domains that I'll cover in a bit, and then also the tiny banker kind of bank and Trojan. And then finally, by looking at the registrant email, you're also able to kind of distinguish between domains that are registered by researchers. So this is, again, a way to kind of weed out all of the false positives that might pollute your kind of data set. And Anthony will cover more about the kind of researchers' approach in registering and sinkholing domains. Now, the next kind of method is to look at client query patterns. So as I mentioned earlier, we have traffic coming from the users to our resolver. So that allows us to see a lot of behavior on the client side. So what we do is basically build some kind of a bipartite graph between the client IPs and the domains they are looking up or like querying. And then you take time windows, so that allows you to see what we call co-occurring domains, because they are appearing during a short time period, and the clients are kind of querying them like in a sequence. So it's either infected machines that are, let's say, having sequential DGA lookups, and a lot of them are NX domains, and some of them will resolve, so that gives you a lot of intel. And I mean, some other researchers use this method, but it's very effective given certain constraints. And then also, it's very useful if you're looking at themes or campaigns. So if users or clients start looking up domains that are related to a certain subject, I don't know, like like Charlie Hebdo recently, the unfortunate events in France, or any other event, you'll see that a lot of people are looking up these domains, and from a seed domain, you'll find a lot of other related domains in terms of theme or like topic. And I'll cover like an interesting example in a bit. Also, we saw that like with real examples that usually when you have a compromised site, like oftentimes, let's say a high-profile site that gets injected with iframe, like it's compromised with an iframe injection that redirects you to an exploit kit site or malware dropping, you'll see that the clients, they will go to the site, and then later on they will look up the exploit kit domain because they were just redirected. So we see that in our traffic, and you're able to kind of derive intel about that. Now the example I want to cover here, it's kind of interesting. So during the target breach a few months ago or last year, we saw a spike in lookups to carding sites. So we kind of tried this experiment. So we started with like a seed of carding sites. A bunch of them, you can find them on the internet or by just looking at our traffic. And then we used like a bunch of other heuristics, either via the hosting infrastructure or via the client kind of query lookups, or the co-occurring domains as I explained. So again, like some of these sites are kind of interesting. They offer you like dumps and bins for anyone who wants to buy. And then by using that client to domain within a short time period, the co-occurrences model, you are able to collect or detect a lot more domains that you didn't know about before. So these are like some other examples of carding sites or stolen credential sites we discovered by using this methodology. So it's quite effective to kind of catch malicious domains and also kind of suspicious content. And again, like some of the things you can discover, you can just browse them and see the kind of the interests that are current in the kind of underground community. So again, this is like a starting point, so you can go like and do extra intelligence about the content of these websites. Now, the next method is to do correlation via malware artifacts. And again, this is a quite simple approach, but it's quite effective. So you start with domains detected by traffic, since we have a lot of traffic, and that's kind of our focal point here. So we start with domains we catch by using models that are either traffic-based or infrastructure-based. And then you go and pivot around the samples that looked up, the samples where those domains or IPs appeared. And then you extract all of the domains that have been queried within those network traces of those MD5s. And then once you get like a bigger sample of domains or IPs, you can just do filtering and extract the ones that are interesting to you. And we see this a lot with kind of banking Trojans, like Tiny Banker is easily detectable with this, a lot of DGAs, and also some other kind of malware samples that you can kind of... So the point here is that if you don't catch everything using the DNS or IP, you can kind of catch up with the sample, or if you start with a sample and you don't catch everything, you can catch up with the IP infrastructure or the kind of client domain query pattern. Now, these are some of the filtering heuristics. Some you might know, some you might find interesting or useful, so you can kind of filter by similar traffic patterns. So if you see like spikes in traffic, and if you see like the same shape of traffic curve, so that's like a very accurate heuristic we found to relate like domains that are delivering the same attack. And then you can also look at the lexical features of the domains, again, like the DGA approach that has been known for a long time. You can also look at the IP infrastructure, the way they're hosted, the subdomain kind of structure or lexical features. You can also go and scrape the content of the websites, as you all know. And then you can also use like the URL pattern, so that's also a very effective heuristic, whether you have like the third-party feeds, or if you sync all the domains, or if you have your own sandbox to run them and grab like the network trace. And then some open sources that you can use for that to get these reports. You have VirusTotal, obviously. Total Hash is very awesome. Malware, Threat Experts, Sophos, and Microsoft have some good kind of threat reports. This one is also, if you kind of don't have enough budget to use commercial solutions, you can just go and web scrape the malware samples or reports. And we kind of experimented with this, and you can get like some really good data sets with this. So if you use like open proxies to prevent throttling or blocking your source IP, you can get a lot of good intel by just using open source kind of repositories of samples and reports.
And so finally we have sinkholing. So this could arguably be put into the active category instead of the passive category, because you're interacting with clients sometimes. And this sinkholing gives you validation on a domain. So if you think that a domain is being used for a particular malware family, you can sinkhole the domain and inspect application layer traffic and see if that actually matches the particular malware's protocol. You can also get URL patterns from sinkholes or other signature type stuff. And you can then correlate that against the things that you've scraped from VirusTotal or Total Hash. So lastly, some other sources of intel. Of course, Google is your best friend. You should learn your search modifiers. Friends and colleagues, like asking around the community, is always really useful. But intel is it's difficult to do just by word of mouth, and it needs to be automated. Like, you should have machines talking to machines and try to remove humans as much as possible so that things can also scale and grow large, especially in our situation where we have millions of domains and IPs that we see every day. But you want to remain accurate, where sort of human validation should be done when necessary and only when necessary. Anyway, soapbox over.
Okay, so now let's get into the use cases. So the first one, we'll cover this ZBot proxy network. So it's a fast flux proxy infrastructure. All of you know what fast flux is. It's a domain that resolves to a single IP with a 0 TTL, so you'll get a new IP every second you do a dig. Or it's a lot of IPs scattered across a lot of prefixes, ASNs, and country codes. And they're typically used for Trojan CNCs, spam, scam, pharmacy, and dating domains. Now, this ZBot proxy network we're talking about, it's basically these fast flux domains that have a TTL of 150 seconds. I'm sure a lot of you have seen this, but this is kind of an effective and efficient process we use to catch these. So you start with a seed of domains that you are 100% sure they are part of that infrastructure, and then you get the IP TTL from our real-time DNSDB. And then we extract the entries where the TTL is, the IPs where the TTL is only 150 seconds. And then we do a reverse lookup to grab all of the domains that resolve to those specific IPs. And once you get those domains, you're sure they are part of that fast flux kind of batch. And you eliminated any parked domains or kind of sinkhole ones. And then finally, you can take those IPs that are confirmed and add them to your pool of kind of proxy network infrastructure. So here we have like two parallel processes. One is tracking the domains, and then one is tracking the IP infrastructure to see how it grows and how it kind of evolves in delivering these CNC domains. Now again, for details, you can check our BotConf talk back in December of 2014, where I gave like more ample details. So this proxy network is hosting a lot of malware families, mainly Zeus. So we have like the different variants, Zeus, Citadel, Kins, and Ice9, but also a lot of malware of other type. We have Tiny Banker recently, starting mid-November, and also a few more, like the new GameOver Zeus, in fact, used it for a day or two when it came back to life. in last July. Like the tiny banker CNCs, the way we were catching them, it's a simple approach but quite effective. So again, we catch them via the FastFlex model, and then we get the network reports for all of the samples that have been looking up these domains, and then you expand your kind of net to get everything else, and then you apply filtering heuristics. Mainly in this case, I use like the DGA kind of features and some other kind of heuristics to only extract the tiny banker domains. Because a lot of time the sample will do like some smoke screen lookups to kind of, let's say, check connectivity or throw you off. So some takeaways about this FastFlex proxy network. This one was an interesting anecdote. So by monitoring this infrastructure, we found some funny kind of stories or like this thing. So this suspended -domains.nic.biz, it looked like it's a suspended domain. It has been sinkholed or taken down, when in fact it's a live one that is being used as a name server for these tiny banker domains. And the actors behind it try to kind of evade and throw you off by making you think it's already gone or useless or not worth your attention. And then actually all of those NS, like the A to D or DNS1 to DNS4, they're authoritative for these FastFlex tiny banker CNCs, and they're themselves hosted on the same proxy network infrastructure. So this is a typical case of double flex, because both the CNCs and their name servers are using the FastFlex infrastructure. Now I want to go into the registrars used for the CNC domains of ZBot. So a lot of abuse in the Russian registrars like R01. You can see like 2 clusters there. Tudaynik is also very abused. Anthony will cover that in Zeus GameOver. So this registrar is kind of the one of choice for both campaigns. And also we have Melbourne IT that will also appear in the Zeus GameOver case. Now another interesting source you can use, spamtrackers.eu. This site will give you a lot of useful information about registrars and how they are being abused and used for spam and fraud domains and kind of malicious content. So again, it can give you like some extra intel about what you're looking at. And finally, this one is about the registrant emails used to register the CNC domains for this ZBot infrastructure. And what we did is basically take the 2LD from the email address, and then we look if there's like an MX record. And basically, to decide if this domain is actually representing like a SMTP relay, so if you send an email, it's going to work or not, or if it's just a fake email just entered there in the form that the guy filled out when he registered the domain. So we see a lot of no MX records, so a lot of them are fake kind of registrant emails, but we also see a lot of fake mail generator. I'm sure a lot of you know about it. You can just go and kind of create an entire identity and use it to fill out forms and kind of get on forums and register stuff. And also a lot of GMX 85.85 mail, which forwards to Gmail, and a few more kind of domains.
So the second case study in this presentation is the new variant of GameOver Zeus, not to be confused with the old variant of GameOver Zeus. This is just the new variant. So a little bit of background. What is a DGA? It's a method of contacting a C2 server using an algorithm to generate a whole list of domains. It was popularized by Configure back in 2008, so it's been around for a while. Algorithms are typically seated on time or date, and then we've observed 2 different kinds of DGAs. One is letter-based and one is dictionary-based, where each individual letter will be calculated separately, so it'll look like just a jumble of letters. And there's also the dictionary-based is then it uses a word list and randomly selects 3 or 4 words from the list and then munges them together to create a domain name. The NuGAS was letter-based, and it was kind of interesting because it added salts to the algorithm. So each owner could add his own salt, perhaps. I'm not sure why, and it would sort of change the algorithm a little bit, so it's more difficult to track. The 2 salts combined would generate 11,000 possible domains per day, and the information that I'll present is for a 62-day period beginning October 7th through December 7th. So just a general sort of workflow of tracking a DGA is something similar to this, where you first have to identify that a DGA exists, right? You can't track something if you don't know it's around. Typically, then the next step would be to find samples that use the DGA and reverse the samples to get the actual algorithm. You could then implement the algorithm in something like Python or Perl or some other scripting language and use that to predict the C2 domains for any date. So if you know the algorithm that's being used, it's kind of like the shared secret between the botnet operator and the malware samples, then you know the list of C2 domains. Once you can identify, the 11,000 domains that will possibly be used for C2 in a single day, you can start resolving them as soon as UTC hits midnight. And whatever domains resolve are most likely the C2 domains. So you can slim down your list from 11,000 to 5. Once you've identified those 5, you can then probe them for more information, and then go back to your passive data and enrich whatever you've collected with probes with your passive information. So in the 62-day period, we found 251 different C2 domains that resolved. That includes researchers and actual malicious domains. And in the middle there, we have a table of TTLs used for each domain. So it's kind of interesting that a TTL is set by whoever's operating the name server. And in this case, the name servers for GameOver Zeus were operated by the malicious people. So they had to go and set their own TTL, which you can kind of see, like, if someone has to set something themselves, it's sort of like a signature for them. We found that most researchers set their TTLs above 300, while all malicious domains were at 300. And if you sum up that domain count column, you'll see that it's more than 251, and that's because some domains changed owners. So it was originally 300, and then maybe it moved to 10,800 or something. So we found 31 authoritative domains for these C2 domains. 21 of the name servers had both NS1 and NS2 pairs. 5 of the domains we are very sure that they're researchers, but not completely sure because we haven't actually contacted the researchers or asked around. 4 of the name servers were eventually parked, and that was either because they weren't resolving at some point or they were never actually registered, not sure. Here's a list of all of the name servers that we came across. And then here's it broken down by malicious versus researchers. You can see on the left 2 columns that NS1 was usually there for the domain, or always there for the domain, and NS2 was sometimes there, which is kind of interesting. We're not sure why. So this is a list of all the registrars used to register C2 domains, including researchers. Sorry. And this is the domains in blue to the registrar in red. And the blue circles represent researchers, and the orange circles represent actual malicious infrastructure. You can see TodayNick and Melbourne IT, again, the top abused registrars. Melbourne IT had a response time of not a number because they haven't gotten back to me, and TodayNick got back to me within a week. So it's kind of interesting that these top abused registrars take really long times to get back to you about abuse complaints. So we also looked at the email addresses used to register domains, both C2 and name servers, and we found 99 different registrant emails, and we tried to filter out researcher emails. Some of the email accounts were created with hosting or with email providers, and some of them weren't. And we found this kind of interesting pattern where a lot of the email accounts were very similar to each other, with one letter sort of moved around or replaced. And that we're not sure why that occurred. So here's a graph of the MX record and the email address. The blue circles represent the email addresses that use privacy protection, while the orange circles were free email providers.
So one observation, quick one about the TodayNick and Melbourne IT. As we saw, they're both kind of abused in the ZBot and the GameOver Zeus. And this might be kind of a best practice among these gangs, where they know these top abuse registrars will either have like a long response time, or they're either complicit or very lax, or maybe they don't have enough kind of staff to respond to these abuse reports. So again, this is kind of an interesting way to see the preferences of these bad actors.
So looking at the hosting providers for the IP addresses used by C2 and name servers, we found 54 unique hosting locations, 3 of which we could identify as researchers. There is probably more in our list. We found a mix of dedicated servers like ISPs such as mobile ISPs and like home DSL lines, as well as some compromised systems. Here's a list of all the hosting providers that we came across. And there's a few universities, as well as the France's Ministry of Transportation, which is kind of interesting. Like, that's definitely a compromised system out there. If you own any of these networks and you don't know that you're hosting Gauze C2 domains, come find me and we can help track down like what IP address it's coming from, what domains are being hosted on it, and all that good stuff. This is a graph of the C2 domains in blue, the C2 IP addresses in purple, and the name server IP addresses in brown, and the size of the node represents its connectivity. So the more it's connected, the larger it is. And we were able to sort of identify sinkholes as well as other researchers based on this method. And the big orange circle is the badness that you want to stay away from. I'm sorry? Give me a circle, tell me how many numbers that is. Hold on. So he asked how big is a circle, basically. How much?
One of those purple, one of the browns, one of the whatever. Just tell me how many that is.
How connected it is?
Context.
Hold on.
I assume that it's not just that graph. I assume there's lots of, you can iterate down into it. It's an impressive graph, but without context, it's tough to understand how big that actually is.
Correct. Hold on. It's like off screen.
Can we answer once we're done, if you don't mind? We'll get back to you.
Okay. New Gauze now. We haven't seen any new domains registered since the 12th of November that were used maliciously. We're not sure why. We can speculate and say that maybe the botnet wasn't resilient without a peer-to-peer mechanism, or it was abandoned for a new malware family, or there was some silent takedown that law enforcement can't talk about. But we have noticed that the researcher sinkholes are still active. They're still actively registering domains. So looking at the previous version of Gauze, up to now we've been talking about the new Gauze variant. This is the old Gauze variant. Kind of interesting looking at query patterns, or client query patterns. The old Gauze version generated 1,000 domains every 7 days, starting at the first chunk of the month and going forward. And if you look at client query patterns, you can see that a single domain from the old Gauze algorithm did indeed last a whole week. So you see a sharp spike on the 7th, and then once it reached the 14th, it immediately dropped off, and we didn't see any more queries for that domain. This is the current cycle for the algorithm. So it looks like it started on the 14th. And then looking at client queries for the new Gauze, which is what we were talking about previously, the two salts, one of them generated 1,000 domains, the other generated 10,000 domains, and the C2 domains were only live for a single day, which you see here. So some of the takeaways from this case study, TTLs of a domain can be very telling because they're set by whoever owns the name servers of the domain. Round-robin DNS was used by the malicious infrastructure, and it's typically not used by sinkholes, so that's one way of kind of differentiating the two. We talked about registrar preferences, and we So I didn't mention this in the talk, but I have a blog on it, on the OpenDNS blog, about the resolution to registration time difference, and we noticed that malicious domains were registered less than a day before they started resolving, which is kind of interesting. We talked about the registrant email patterns, and the fact that there were many IPs to many name servers in the graph the gentleman asked about, and also the fact that there were compromised as well as dedicated systems. So the system that I generalized earlier in the previous table, it was Bash glued together with some Python, glued together with some C, and it was really ugly. So we rewrote it, and we have this tool called SnapShooter that will essentially track DGAs for you that we're releasing. Hooray. The output is JSON instead of flat text. It's a client-worker kind of model. Here's a basic diagram of how it works. You've got a client, a bunch of workers that have daemons on them. Client generates the domains for the DGA, tries to resolve those to see which ones are live, spins up processes that map to workers and distribute the domains to each worker. And the worker can then go do DNS queries to get original TTLs, IP addresses, as well as contact whois servers for both authoritative domains and C2 domains and grab that information, pull it back. And the client just writes it to a file, basically. So something kind of novel that we came up with for this, this tool. Whois servers throttle, and that's really annoying. Especially when the registrar won't just give you information, you have to use whois. So we use passive DNS to basically rotate between IP addresses that a single whois server resolved to. So when you type whois and some domain, the whois client will actually go and issue a DNS lookup for, for example, whois.verisignGRS.com, and then issue the whois query to whatever IP address is given back to you. And instead of doing that, we just go directly to the IP address that we know about from our passive DNS database. If you run this bash script, what it essentially does is it resolves whois.verisignGRS.com 20 times and then spits out the counts for IPs. And on the right, you see the results. So you don't get all the IPs, even if you query for it 20 times, you get a subset of the IPs, which is kind of interesting. So do we have time for a demo? Yeah, go ahead. Yeah? 3 minutes, okay. So the code's online if I don't get through it. Oh, there's the VM. This is going to be interesting because I can't see. Can you guys read that? Yeah. Okay. Sorry. Bear with me. There's no wireless down here? Is there? I don't trust any of the ShmooCon networks. All right, we're gonna do it. All right. So I've got a system called SnapShooter that acts as the client, and we might be able to. Yay! Okay. Yeah. Right. So I've got the client script in this directory, and then above this, I've got a results directory with nothing in it. So I'm just running a watch command on that. And I'll run the client. And what it's doing right now, instead of using the Gauss domains, it's actually looking up the Alexa top 25 and distributing that to my workers. And as the results come back, the file gets written to that results directory. Let's see. Sometimes it takes a little while. The workers try really hard. They're chugging along. All right, so we'll look at, there comes one. So we'll look at Amazon. And there's a big JSON blob that's really ugly to look at. But I've got an example of the output on the GitHub that's pretty formatted. It looks something like that. You can see, all the whois stuff, how each name server responded, what IP address, TTL, all that good information.
So it can track everything for you, like if you feed it with a list of domains.
Just really quick, some to-dos. Automatically contact registrars with complaints, scrape content if there's like a web server, back the whole thing with a graph database, and pray that the RDAP draft passes so that whois is JSON formatted by default.
So I'll skip through the conclusion. I'll just show the references. So if you need more information, check our Black Hat and DEF CON virus bulletin and BotConf docs. We have a lot more details. And then some other kind of references and tools that are very useful, so we give credit to them. And finally...
Thanks OpenDNS, thanks ShmooCon, thanks Arbor Networks. John, you're a badass.
And if you have any questions, please go ahead.